Do you think there is an upper limit to human aging? Yeah.
It's not even a question. I'm not exaggerating when I think a whole body reset is coming. Your nerves regrow, your spine regenerates, etc.
Amazing.
There is no law that says we must age. Remember that. There's a backup copy of information in every cell. And that fact changes everything.
It's a very big deal.
I'm no longer talking about slowing aging. I'm talking about true age reversal multiple times.
David Sinclair est un biologiste d'origine australienne. C'est un professeur de génétique et cofondateur d'une société de biotech à la Harvard Medical School. Et aujourd'hui, il va nous montrer un petit peu l'état des lieux de ses recherches actuelles. Préparez-vous à avoir un choc quand même, c'est juste impressionnant. Et c'est pas une blague, il se passe vraiment des choses incroyables dans les labos actuellement. Sur ce, bon visionnage et je vous retrouve juste après.
I was inspired by my grandmother who told me that humans can do better. That's the vision. It's that we can always do better. There's a bright horizon that we need to get to. We need to steer humanity in that direction. And so she said when I was 4 years old that everybody I knew, including my pets, were going to die. And it's not going to be pretty. And then I'm going to die. And as a 4-year-old, that was a bit of a shock to be told that. And we all learn this around the same age, but we forget about it because it's too painful to live every day knowing that fact. As sentient beings, as conscious animals, it's really a burden that we bear. And I thought that wasn't fair to have consciousness and to know that we were going to be sick and die and watch everyone else die. That was at age 4. And then at age around 15, 16, I thought this new technology called genetic engineering could actually tackle this problem in a way that had never been done before. So I set my sights on that. Yeah, so the information theory of aging, as it's called, I formulated when I was still in my 20s. I woke up in the middle of the night. And that's the idea that aging isn't just damage to the body like we wear out. It's actually a loss of information that we inherited from our parents and built on during development. And by understanding, I think, a large part of why we age, we were able to control the aging process in a colony of mice, driving them forwards and backwards in their age and making them get diseases. And now we're even reversing those.
One of the questions I'd love you to share, or the answers I'd love you to share is, do you think there is an upper limit to human aging?
Well, I know there isn't.
You know there is not.
Yeah. It's not even a question.
Drop the mic moment.
Let me explain. There are lots of reasons why I give that answer. To me, it's self-evident, but for some people, it isn't. And there are critics of this idea that we can live beyond 120. But one of the best examples is that we've been able to extend the lifespan of every species that we've tried to extend the lifespan of, and we're no different from those species. That's point one. The second is that there are many species who are very similar to us genetically, biologically, that live a lot longer than we do. The best example would be the bowhead whale, but a lot of whales live longer than us. And that, they have children, they're conscious, they produce milk. So we just need to mimic what they have that allows them to live so long. And I think we have a much better idea now of how to do that. And so, yeah, there is no law that says we must age. Remember that. So we're already many decades ahead of where I thought we would be technologically from when I started. I thought I was working to help my children and future children and grandchildren, but it turns out that the pace of discovery has gone way faster, and that's partly due to technology. We can now do an experiment that analyzes billions of genes in the same time frame in a day that used to take us years of work and billions of dollars, and that allows us to do very quick experiments. The other thing that makes me super positive about this is that I think we've made a major breakthrough in our understanding of not just why we age, but also how to control that process. And the turning point in my career was the discovery that there's a backup copy of information in every cell, in every body's cells, and that backup copy can be accessed, and there's a switch that you can flip that allows cells to reset their biological age and function again as though they were young, because literally they are young again. And that fact that there is a backup copy changes everything. I'm no longer talking about slowing aging. I'm talking about true age reversal multiple times. And I don't get laughed off stage anymore when I say that.
The evidence that you have for this backup copy, there are a few things you speak about in your book and your podcast. Could you speak just a few examples there?
Right. Let's see. We've got some visuals we could call up, actually. Yeah. Let's do a show of hands. So how many of you have heard of the epigenome, or at least epigenetics?
Hopefully everybody's raising your hand.
Okay. All right, we're done. Good.
They're all good students.
All right, so the concept is that what we've realized is that most of disease and disability is not driven by our genes. It's actually controlled by the regulator of those genes, which is the epigenome. One of the best examples of that are these people here. So these are individuals from two sets of twins. These are in Denmark, a very large study of Danish twins, looking at the effects of genes versus environment, or epigenetics, which is what responds to the environment. And so if we click the button forward once, you'll see that the identical twin of these two individuals, hopefully you can see, looks a lot younger and is actually younger biologically. We can now measure that. And it turns out that by living a healthy lifestyle, often you hear about doctors recommending these things. We know a lot about how to slow down the aging process. You don't just look younger, you actually are biologically younger. And that's why if you exercise, you eat right, you eat less often, you take the right supplements, you will be biologically younger and you will actually stave off disease until much later. So what does that actually mean? If we go back one slide, the concept is information. So the main type of information that we know about is the genome in the DNA. But there's also another level of information that's just as important and even more complex. That's the epigenome. And those are the structures that control how the DNA is bundled and shaped, and which genes out of the 25,000 get turned on and off when we're forming an embryo and we develop. And those genes can be switched on and off depending on how we live. If we put our bodies in a state of perceived adversity, or adversity that isn't too damaging, the epigenome will actually respond and be more stable. So the idea is you want to stabilize your epigenome so that your cells remember how to function youthfully for longer. The analogy, as shown in this slide, is a compact disc. Hopefully all of you remember what those things are.
Barely.
Incredible technology. You could fit about 20 songs on there. When I teach at Harvard, the kids are like, what are you talking about? This is ridiculous. So if you're young, it's like resetting a computer or pressing the buttons on the side of your iPhone. So what the analogy is, that the digital information is the DNA, and that's the music, but you need to read it. It's not just bits on a metallic disc. The epigenome is the equivalent of the reader of that information, and the songs are the genes. And aging, I believe, is akin to scratches on the CD, so that the cells still have the music, the genes, but they're just not read correctly at the right time in the right place, so that your cells forget how to work. So we see that brain cells become more like skin cells, and skin cells become more like kidney cells. We become a melange instead of highly differentiated, functioning, youthful cells. And so that's the information theory of aging. And what we found out in this paper is what drives that process, in large part, is broken DNA. Avoid X-rays, CT scans, if you can help it. Don't fly too much.
If you can help it.
Yeah, well, don't do what I do. And live ways that actually prevent those breaks, because that disrupts the epigenome we showed. But here's the cool point, is that we've discovered you can polish off those scratches and get back the beautiful music of cells and their youth.
There's a concept that has been talked about for some time of longevity escape velocity. That there's a moment in time that for every year that you're alive, science can extend your life for more than a year. Where are you on this, and what do you think will reach longevity escape velocity? How far out are we?
Let me give you an update on where we are today.
Please, and whatever you're willing to say. I know some of it's amazing.
The journey has been a rapid one. We made this discovery that you can reset the age of cells, human tissue, mouse tissue, living mice. What is it now? It's about 5 years ago. It was published 3 years ago. We started working on mice. We reset the eyeballs of mice to be young again. They got their vision back. We've done extensive studies in mice. We needed to know if it was safe. It's very safe. We've never seen anything negative after years of work and driving this process. We found that those 3 genes, O, S, and K for short, these are gene regulators that set off a cascade of events during embryogenesis to make a young human. Turns out, lucky for all of us, I think, is that those 3 genes also set back the clock in adult cells without causing tumors or any disease.
And without bringing them back so far that they've lost identity.
And this is the thing that blows my mind is you'd think that if you just keep it on for a long time, you'd go back to zero, age 0, which you don't want. It's not true. Cells go back about 80% and stop. There's a barrier that prevents them from going back to 0 if we leave off that other gene. It's a gift to humanity.
For sure.
And so now we're at the point where we're conducting, at Life Biosciences, a Boston-based company, non-human primates. These are green monkey studies. I should say that the reason that there's an iris on this cover is that we show that you could reverse blindness due to glaucoma and also old age by resetting the age of the retina back to youth. And those mice got their full vision back again. So think about this, your body, if this is true, the body looks old, but it just needs to be reset. So I don't think of an old person now as an old person. I think it's just a body that needs to be reset.
Polished.
Yeah.
So this is a big deal because, I mean, one of the critiques about the work that you and other individuals in this field have done is it's all done in mice. You know, that's great, but we're humans, you know, mice get all the benefits. But non-human primates is a big deal. We share 99.99% of our genetic code with them. We do,
so I've had a sneak peek at the results, and I would say things look rather promising at this point.
It's a big deal, guys. It's a very big deal.
And so it's my prediction that we'll be, in the next 18 months or 2 years, testing our first age reversal clinical trial in humans to cure blindness. And those studies are actually being planned right now, and the material to do that is being manufactured. Yeah, I don't know if you had this experience, but every day I go into my lab and I'm surprised how small it is. It's just like Elon Musk says, if you have dedicated people who know really how to make a difference and look forward rather than today. To me, it's amazing to walk in there, and I never get tired of showing people around because it's like magic. You go in and you see, actually, I think the next slide might be interesting. Click to the right, and what you'll see is that we're now growing human brains. Have any of you seen
these organoids?
To grow these organoids? Probably many of you have seen this. So on the left, we have cerebral organoids grown from human tissue. We can now, I think we're the only lab now that can make these brains get really old. We can make them 70 years old within a matter of weeks. Now they develop dementia. We can measure that with these electrodes on the right. We grow them on these little electrodes. And then we reverse the age of those little organoids, and they get their thinking ability back, whatever that is. We do see the electrical activity come back. But why do we do that? It's not just cool. It actually tells us that the whole brain is reversible. And we've actually done this now in mice. We haven't published this, so you've heard it here first, that we can reverse the age of an old mouse's brain. So they have dementia. We spend 3 weeks reversing the age of the brain. We just give them an intravenous injection of our therapy, turn it on for 4 weeks, and those mice have a young brain, and they have their ability to learn again. So I imagine a day where we will have an infusion either in our eye or in our whole body, and we just take a drug to turn those genes on.
And we will have the ability to go and get a mechanism that will allow us to basically age in place or age in reverse, so that we're no longer, if every year we're alive, we're extending our lifespan for more than a year.
Well, it's already here. It's just not available widely.
It's already here, ladies and gentlemen. At least if you're a mouse.
Well, so I'm not talking about our therapy. That's hardcore. That's a rocket versus the Wright brothers. But there are technologies now and some published papers that.
Are you talking about like rapamycin?
Rapamycin and combinations. So Greg Fahey has done good work, continues to do good work on combinations of molecules that have age reversal properties. So I believe that there are already molecules and drugs that you can use to reset your age somewhat, not go back to being 30 years old again if you're my age. Our ability in my lab, and presumably scientists across the world if they're smart, to use AI to answer questions that we were not able to. Just ability to ask AI how to find the best molecules. You can ask AI that. You can get decent answers. So we are going to have exponential increases in the pace of this field.
One of the points I remember in discussion with you and George Church was that it's likely that a real rejuvenation therapeutic will, if it works for one tissue and organ, will work for the entire body.
That's also lucky, but it's true. That's what we find in animals. Now, I haven't injected myself yet. I'm probably not going to do that for a few years. But in mice, I'm shocked that what works in the eye, in the optic nerves, the nerve cells, works in the epithelial cells in the retina, works in the outer layer of cells on the retina, works in the kidney we just published, the muscle. If it works in all those different cell types, I think it's a universal process of biology to be able to be reset. And so that's why I'm not exaggerating when I think a whole body reset is coming.
Amazing. One of the things that we talk about on the longevity platinum trips usually is this idea of gene therapies using these molecular robots, the adeno-associated viruses, and where you can target your virus towards particular tissues.
Well, that's what we do. We have a domesticated virus, the AAV, which is already used and approved by the FDA. Our system's a little bit more advanced, the one that we co-developed with George. And that is, it's a two-part system. Right now, as far as I'm aware, nobody else is developing a product for in the clinic that has an on-off switch. I think that's important for two reasons to make that happen, even though it's triply expensive.
Can I just as you're setting this up, you're saying we're going to put these three genes, the OSK genes, in all the cells of your body, but we're going to have to turn it on, otherwise it's inactive.
It starts out off, correct. Yeah, and that's what we did in this paper in Nature and this new one in Cell, is that we have exquisite control over when these genes come on for safety reasons, but also because we now know, in the mice at least, you can reset multiple times. So that you'll have this treatment, your body will be filled with these genes, they'll be off, and if we get sick, or if we get injured, or if we get too old, we can take a course of an antibiotic for a couple of months and get reset every time. Or if we're in the emergency room, they give you an infusion of doxycycline, on come these repair genes, your nerves regrow, your spine regenerates, etc.
Amazing. Amazing. Where are you? What if you had unlimited funding, which hopefully you will, you don't yet, where would you be experimenting? Where would you be going next?
Yeah, I would put a lot of effort in the next generation of age reversal technologies. Right now it's a gene therapy, which means it's going to be expensive and hard to fulfill our dreams of changing humanity. That said, what we want to do is we want to turn those gene therapies into a pill.
Let's talk about a few of the molecules people have heard about. Where are we on NMN, which you speak about elegantly in Lifespan, and which has now entered some interesting human clinical trials in partnership with the military?
Yeah, that's right. So NAD, again, a show of hands so I know where to pitch it. And everybody knows of NAD now and heard of NMN. Great. So most of you, and if you've read my book, you certainly know. So for those of you who don't know, very briefly, NAD is a molecule required for life. It's one of the most abundant molecules in our body, and we make less of it and destroy more of it as we get older. And this is a molecule behind me called NMN. It's one of a small group of chemicals that we make normally, but we can also eat. We can swallow, we can inject, that raise those levels of NAD back to youthful levels. And we've published that this molecule taken at a gram or 2 gram levels in humans, just swallowed every day, will double or triple your NAD levels, which is good because
as we age,
people our age have
drops a lot.
half the levels that we once did. So that's not just important because we lack energy without this molecule. It's required for about 500 chemical reactions in the body. There's a second reason why NAD is important. There are enzymes in our body that we've worked on my whole career called sirtuins that don't protect the body against aging unless they have NAD. And as your levels go down, your body doesn't fight aging as well. And that's one of the reasons you get older faster as you get older, right? So we know our parents, our grandparents fall off a cliff age-wise, health-wise. One of the reasons is our NAD levels fall exponentially. So we can replenish that. We've got clinical studies now that show that it's not just possible to raise NAD levels, but when you do that, you have health improvements in humans. These were studies out of Harvard. I was not involved. And so what they showed was lowering of cholesterol, lowering of blood pressure. Looks a lot like we got in mice, improved endurance. So we're starting to learn that what we saw in the mice, which was, I haven't published this, but increased lifespan, improved health, less frailty, protection from radiation, which is why we should take these molecules while flying or taking an X-ray. Long story short, we're starting to see translation of what we discovered in mice occur in humans, and there are over I think we're starting our 6th human clinical trial with a version of NMN which is crystalline and stabilized. It'll be used widely for many diseases. You might be wondering, what are these 5 clinical trials? They're, if I can remember some of them, kidney failure during COVID. There's an endurance one from the military. I got in trouble saying that a few years ago on Joe Rogan, but now they publicize it, so I'm okay telling you.
This is the special forces are using it to help measure increasing strength, but also increasing cognitive focus during periods of extreme activity.
Right. It's also being used for, brain fog after surgery.
Yeah.
And also in a cancer trial. So it's pretty broad, and I'm optimistic.
You pinned a tweet in which you talk about the factors that are counter to a longer, healthier life. Smoking, for sure.
That's the worst.
The worst. Alcohol intake.
Again, new data says alcohol is worse than I even thought.
So if you want your resveratrol, take the pill, not the red wine.
Definitely.
Okay. Waist size.
Yeah. People who are overweight have, in general, an older epigenetic age than those who stay at a BMI between, say, 21 and 24. So that's a fact. So if you want to age slower, maintain your BMI in what's considered a healthy range.
Inflammatory, CRP levels. Yep, I think it's...
Yeah, it's called
inflammation is the underlying killer for so much.
For sure. And there are foods that you eat that can be inflammatory. For instance, some of us have a reaction to dairy or to certain grains. Be careful about that. You don't want that. Your gut is very important for inflammation. You don't want bacteria getting into your gut, lodging in your bloodstream or in your brain. That can cause these diseases that we all know of. So yeah, keep inflammation low. And one of the best ways to do that is to not just eat well, but also make sure that you're not allergic to things in your environment. And you can do blood tests to make sure that's not happening.
David, it's an honor to call you as a friend. I'm grateful to have you here. Thank you for all you're doing.
Likewise, sir. Thank you, sir.